Good morning.
Good morning, sir.
Can you listen to me?
Yes, sir.
Yes, sir.
Okay. So let us start with problems which are based on relative velocity method. Okay. So are you ready to begin? Like what I said you to arrange the drawing instruments. Have you done that? Or should I wait for 5 minutes more? Guys, have you arranged the drawing instruments?
Yes, sir.
Okay. So just for a minute, can you put on the video and show me the drawing instruments, everyone? So I will ask first for Jerome. Tarun, did you manage to have the one?
So I'm just arranging for a few things.
Okay. So at least you can pay attention and record or note down the important things from the lecture. Okay. So I will explain you this method known as relative velocity method, right? So before doing that, I will one more time explain you that what is important here. Okay, so this particular topic is very important. This concept that if the 2 points are on the same link, for example here, and if you write the velocity of one point, for example, velocity of point B with respect to point A, then the direction of this velocity will always be perpendicular to the line which is joining the points A and B. Okay, so you know the direction, you know that a vector has both direction and magnitude. In order to draw a vector, you need both things. You need magnitude as well as direction. So this is one concept which will help you. Okay, so you need to remember this. Again, and for magnitude you remember, see, you are writing like this velocity of point B with respect to point A. So you know that velocity is radius multiplied by angular velocity. So how to take the radius? Radius for point B, point A acts as center. So radius will be for point B, it will be nothing but distance between these 2 points, AB. Then what is the angular velocity of the link on which this point is present, point B or point A? So angular velocity of that particular link. This way you will find the magnitude. For direction, I have given you the hint that it will be perpendicular to the line which is joining these 2 points. Okay, so once you know the magnitude and direction, you can proceed to draw the vector. Okay, so now let us proceed for the problem. Okay, it is one point, and in order to use this formula, you remember that both of these points A and B are on same link, right? On same link, I'm repeating. Next is, it is also important to label this vector velocity of B with respect to A. So it is labeled in opposite way. Like the name of this vector will be small a b, small ab. It suggests that this particular vector will start from point A, small point A, and terminate at point B. Okay. So labeling is also important thing for the vector. Okay. Now let us solve the problem based on this concept. And while we will be solving the problem, I will also tell other concepts which are generally used in this method of relative velocity method. Okay, so you note it down, this problem, and then let us see how we could solve it using the method we have recently learned. Okay. Put down your papers, leave it as it is. It is better to Okay. So did you note it down?
Yes, sir.
Okay.
Yes, sir.
So one can see that it is a 4-bar chain. Okay, means 4 lines you have to draw. A, B, C, D. In this, AD is fixed and 150 mm long. The crank AB is 40 mm long, means length is given, and it rotates at 120 rpm clockwise. While the link CD is 80 mm and it oscillates about the BC and AD are of equal length. Find the angular velocity of link CD when angle BAD is 60 degrees. So first of all, like you do in ICR method, you have to draw the space diagram, which you also know as your configuration diagram. Okay, so how to imagine this angle BAD is 60 degrees. So if you draw AD, line AD, which is fixed, say this is horizontally fixed AD. So angle BAD is how much? 60 degree. So angle BAD, you can read it like this, or DAB. So this angle, this particular angle will be your 60 degree. Then you take the length AB. AB का length कितना है? Length of AB is how much?
40 mm.
40 mm. So now you decide whether you want to keep it 40 mm or you can reduce it if it is not possible to fit the size of the 4-bar chain here. So maximum size given is 150 mm AD. So you can select it like this, that scale selected should be 1:2. That is your scale factor you are choosing as 2. Every dimension will get divided by K, that is 2. So length of AD will be 75. AB, length of AB will be 20 mm. Okay, so you will locate the 20 mm. At 20 mm, point B will be located. Then, while the link CD is 80 mm, okay, and it oscillates about the D point. So, link CD will be connected to the D point like this. But angle is not given. Like what is the angle between A, D, C? Okay, so any other thing which is given, BC and AD are of equal length. Okay, so what you will do, BC, BC कितना है? Equal to AD, 150 mm. So you take in compass, 150 means 75 mm in compass. Put the compass at B and you draw an arc. What is the radius for this arc? 75 mm. And you know that this arc we have drawn in order to locate the point C. Point C is going to come on this arc. Next is, uh, what about the CD link? Length CD कितना है? 80 mm. So what you will do? You will take 40 mm in compass. Put the compass at D and draw the another arc. Okay, so this arc is having radius 40 mm and we have drawn it to find the point C. Okay, C point will be on this arc. C point will also be on this arc. So wherever these two arcs will intersect, that will be the common point on both the arc. And this way you can locate the point C. Got it?
Yes, sir.
Yes, sir.
Okay. So you will draw it like this. So you will get this diagram, which is known as configuration diagram. Okay. Now let us do the analysis with the help of relative velocity method. So first of all, what is given to us? Which information is given to us? Let us see regarding the velocity. So here it is given that crank AB, this crank is rotating 120 rpm, 120 rpm clockwise. Okay. So what is given to us is your RPM of link AB. It is given as 120. So you know how to find out the angular velocity, that is in radian per second. If you are using the RPM, there is a relationship between angular velocity what is that, that is 2 pi n upon 60. 2 pi n upon, so you can find out the angular velocity of link AB, and it is given as this link AB is turning in clockwise direction like this. Okay. So if you do the calculations, this is known to us angular velocity of link AB. Now let us proceed towards the finding the velocity. So now I will find what? I will find the velocity of the point which is on crank, which is on crank, because crank का angular velocity हमें पता है, जो link AB है उसका angular velocity हमें पता है. So we will find the velocity of point which is on crank. Okay. So how to do it? So suppose point A is fixed, it won't have any velocity. Okay. So I will find what? I will find the velocity of point B. Okay. Velocity of point B. Now, as it is a relative velocity method, you are finding the velocity of point B with respect to some point. That point is nothing but your point A. Okay. Velocity of B with respect to A. What will be the formula? What will be the formula? Formula will be radius multiplied by angular velocity. So radius for point B will be nothing but the distance between these 2 points, that is AB, because what, you know, both the points are on same length. A and B both are the points on the same length. Then we can use this formula AB into angular velocity of the length on which both of these points are there, AB. A और B दोनों कौन से लिंक पर है? That is link AB. Angular velocity of, so use this equation and find out what is angular velocity of B with respect to A. देखो कितना है?
251.32 per second.
251. Okay. So AB का लेंथ, इफ आप अगर यहाँ पे मेजर करते हो तो यहाँ पे कितना मिलेगा आपको 20 mm, क्योंकि स्केल आपने लिया था, ठीक है। तो दैट 20 mm शुड बी मल्टीप्लाइड बाय द स्केल, उसका ओरिजिनल लेंथ फाइंड आउट करने के लिए। सो 20 इंटू 2 40, ओके, 40 multiplied by angular velocity. So this 2 into 120, right? So 4 pi. Angular velocity कितना है? That is where 4 pi radian per second. So this is the value for.
Sorry, sir, I forgot to multiply this.
Yes, correct.
502.65.
So what is important here is that you have to take the original distance between point A and B. Suppose if you have already reduced the distance between them, okay, in order to select the proper scale, then you need to multiply it by the scale. Okay, that is important here. 160 pi. Now pi value is around 3.14. So this value will
502. 502.4.
502.4, 502.4 mm per, ठीक है, mm per second. Now we have found this value. We know the magnitude of velocity. Okay. Now about the direction. What is the direction of velocity of point B with respect to A? We know that both of these points A and B are on same length. Okay. So the direction of this velocity will be perpendicular to the line which is joining point A and B. So this is the line AB. That is the thing, but link AB, which is joining these 2 points. Okay. So in order to determine the direction, you can see that it is shown like this. This velocity of point B is shown perpendicular to the link AB. Okay. And to be more precise, I will add the point A here, that it is the velocity of B with respect to point A. No doubt it can be written as like this also, that velocity of point B with respect to A is equal to velocity of point B. It can be written like this because now what? Because here A is the fixed point. That's why it is possible to write like this: velocity of B with respect to A is equal to VB. In case A is the fixed point. Okay. If A is not the fixed point, then these two will not be equal. You cannot write that like this. Okay. So see, magnitude आपको पता है, magnitude, और आपको डायरेक्शन भी पता है कि ये डायरेक्शन है, velocity of point B with respect to A. Now you have to draw a vector. Okay. So I have to select a point from where I can draw it. So what I will do, I will select a suitable point which is close to this mechanism. So suppose I will select somewhere here. It is my point from where I will start my drawing. So this reference point is always your fixed point. Which are the fixed point? Point A and point D. So you remember that every fixed point is at same point. Okay, so fixed point is point A first, and point D will be there only here because point D is also fixed point. So I will mark it with small d. Got it?
Yes, sir.
Okay. To draw, to start with, we need some point, reference point, and this reference point is always your fixed point from where we measure the velocity. So on paper, somewhere we marked a point and we have labeled it point A and point D. Okay. Now from this point, I will draw the vector. So I want to draw this vector velocity of B with respect to A. You tell me what will be the label for this? Label क्या करना
A,
है? Yes, small a. बोलो. Small
B,
a b. Right? क्योंकि वेक्टर का नाम अपोजिट होता है. ये वेक्टर कहाँ से स्टार्ट होगा? पॉइंट ए से. पॉइंट ए से स्टार्ट हो रहा है यहाँ से. पॉइंट ए कहाँ पर है? यहाँ पर है. Here it is. यहाँ से आपको स्टार्ट करना है. But you have to draw in particular direction, in specific direction. What is that direction? The direction of this vector is perpendicular to link AB. Link AB को perpendicular है. Means ये direction. अभी आपने ये डायग्राम ऑलरेडी ड्रॉ किया है. ठीक है. This configuration diagram is with you. With the help of drawing instrument, you take the reference of this line. You take the reference of this line and draw perpendicular to this line from this point. Means like suppose just ये आपका हॉरिजॉन्टल लाइन है और ये आपका 60 डिग्री पे लाइन है. तो आपको क्या करना है? 60 डिग्री का जो लाइन है इसके, ये जो इसके पैरेलल है, उसको परपेंडिकुलर लाइन बनाना है. ये लाइन को परपेंडिकुलर इस तरह. ये जो लाइन आ रही है ये लिंक ए बी को परपेंडिकुलर है. देखो, इसीलिए मैंने ये पॉइंट ये डायग्राम के क्लोज लिया था ताकि मैं इसका रेफरेंस ले सकूं बाद में. ठीक है. अभी ये डायरेक्शन तो आपने फाइनलाइज कर लिया है. वेलोसिटी ऑफ पॉइंट बी विथ रिस्पेक्ट टू ए का डायरेक्शन है. कितना मैग्नीट्यूड लेना है? मैग्नीट्यूड इज गिवन हियर 502 mm पर सेकेंड. तो अगर आप स्केल जो वेलोसिटी के लिए जो लेते हो, अगर आप 1 mm per second will be represented by 1 mm. Okay, then what will happen? You have to draw a line of 500 mm, which is not possible to draw in your paper. Okay, so again you have to select some suitable scale for the velocity diagram. Okay, say for configuration diagram I choose the factor k. Now for velocity diagram I will give it some different name. I will say k suffix v. K suffix v. Okay, so how much you can reduce it? How much value you can represent with? It is 500. So say I will represent it by 50 mm. So I will select a velocity factor as 10. I will reduce this value by how much? By a factor of 10. So 500 divided by 10, it will reduce to 50 mm. So this particular line will be of 50 mm length, whatever is the value. Okay, and after 50 mm finding, you mark the end point of the vector. What is that? Point B. Got it?
Yes, sir.
So ये जो लाइन ड्रॉ किया है, to draw it we use certain facts. First, a reference point should be fixed point. तो जो भी फिक्स्ड पॉइंट होगा मैकेनिज्म में ए डी, और अगर कोई दूसरा पॉइंट भी है ई पॉइंट, वो भी फिक्स है, तो वो एक ही जगह पे होगा, सेम पॉइंट. ओके, देन we needed a direction we found by the fact that the direction of velocity of any point with respect to any other point on the same link will be perpendicular to the line which is joining these 2 points. तो ये मिल गया हमें वेलोसिटी. अभी इसको राइट में क्यों लिया, इधर लेफ्ट में क्यों नहीं ड्रॉ किया, ये भी तो परपेंडिकुलर डायरेक्शन है. So you can see that this crank is rotating clockwise. This crank is rotating clockwise. That's why the point B will come downward. It won't go upward. So we selected like this. Okay. And we found the magnitude using this relationship. A vector is drawn. In this way, you complete all the points on this diagram. Okay. Then your velocity diagram is complete. Point B हो गया. अभी देखो. I will move to the next point, point C. Okay. So for point C, I will take what? I will take velocity of point C with respect to which point? With respect to point B. Okay. Now you tell me what will be the formula for this velocity of C with respect to B? क्या formula बनेगा? अभी किसका फाइंड आउट करना है हमें वेलोसिटी? पॉइंट सी का विद रिस्पेक्ट टू बी. ओके.
B.
रेडियस क्या होगा? Radius will be
BC.
BC. Yes, the distance between these 2 points. Angular
Omega
angular velocity of link BC.
BC.
Yes. Formula we are knowing, but can we find its magnitude? For example, we know the length BC 150 mm, हमें वो पता है, लेकिन एंगुलर वेलोसिटी पता है क्या? एंगुलर वेलोसिटी ऑफ लिंक BC गिवन है. नहीं, एंगुलर वेलोसिटी ऑफ लिंक BC इज नॉट गिवन, और हमें एंगुलर वेलोसिटी ऑफ लिंक CD फाइंड आउट करना. सो if angular velocity is not known, we cannot find the magnitude, right? Magnitude is not known to us, means length of the vector we cannot find. Length of the vector हमें पता नहीं है. But do we know the direction? Do we know the direction? क्या डायरेक्शन होगा? वेलोसिटी ऑफ पॉइंट सी विथ रिस्पेक्ट टू पॉइंट बी. ये जो वेलोसिटी है, this velocity will be perpendicular to the line which is joining this 2 point BC. तो ये लाइन BC है, तो इसको परपेंडिकुलर ये इस डायरेक्शन में देखो. अभी मैंने इसको डाउनवर्ड लिया है, आप उसको अपवर्ड भी बना सकते हो, क्योंकि हमारे पास अभी मैग्नीट्यूड तो है नहीं. ठीक है. इट इज व्हाट? इट इज वेलोसिटी ऑफ C with respect to velocity or with respect to point B. डायरेक्शन समझ में आया आपको?